lesson expands on the techniques used to find the determinant of a 3x3 matrix demonstrated in the previous video. Here, we'll calculate the determinant of the 4x4 matrix A equals row 1, 2, -1, 3, 0, row 2, -3, 1, 0, 4, row 3, -2, 1, 4, 1, and row 4, -1, 3, 0, -2. However, it is assumed that you understood the material in the previous video, so the steps to calculate the determinant of a 4x4 matrix will not be explained in as much detail. First, we need to set up the checkerboard of positive and negative signs. We write a positive sign next to the first entry in the upper left-hand corner. Then we alternate signs along the first row and along the first column. Now we alternate the checkerboard signs along each row. Next, we pick a row or column to expand on. I recommend choosing the row or column with the most zeros, as this will make calculating the determinant much easier. So I'm going to choose to expand on column 3. To obtain the determinant of matrix A, we expand on the first entry in column 3 to get 1 times 3 times the determinant of the matrix, row 1, -3, 1, 4, row 2, -2, 1, 1, and row 3, -1, 3, -2. We slap down a plus sign and expand on the second entry in column 3 to get -1 times 0 times, but wait, since we're multiplying by 0, this term will be 0. So we can just write down a 0 here and slap down another plus sign. Next, we expand on the third entry in column 3 to get 1 times 4 times the determinant of the matrix, row 1, 2, -1, 0, row 2, -3, 1, 4, and row 3, -1, 3, -2. And we slap down another plus sign. Now we expand on the last entry in column 3. Oh look, it's another 0. And since we would just be multiplying by 0, we don't need to perform the expansion for this entry. Okay, now we just need to crank out the math. But wait, these determinants are 3x3s, so we need to use the same method, it's actually called expansion by cofactors, to calculate each of these 3x3 determinants. You should push pause and crank through each of the 3x3 determinants yourself. Are you back? I'll just be quiet and quickly run through the steps to calculate each of these 3x3 determinants and then the determinant of the 4x4 matrix A. So we have that the determinant of matrix A is negative 102. To find this 4x4 determinant, we began by applying the method expansion of cofactors to the matrix A, but then we ended up with two 3x3 determinants in the midst of our calculations and had to apply expansion of cofactors to find each of the 3x3 determinants as well. I'm sure you can imagine how tedious finding the determinant of a 5x5 matrix